Hey, what's up, guys? So let's solve this 1997 first day where you have been in all rooms. Oh, so this problem is very interesting, and yeah, basically, there are n rooms. By the way, hope you guys subscribe to my channel. So there are n rooms you need to visit label from 0 to n, and each day is label one a label, and you get 0. You start with 0, and there's a strange array called next visit, and there's a rule is very strange that you visit I. And if you add I r time, then you can you must go to next visit, and there is a strange rule that next visit must less or equal to I, and if you go even, and then you can go to next day. Okay. So for example, and you need to return the results that the first day you have visits all rooms, right? So by the second rule that you know that you must go from left to right. So one step. Okay, so you visit all room the equivalent to you for you to visit the final room. Okay. So 0, 0. The answer is 2. Because in day 0 you are 0, right? And so by rules, you must go to next visits because you only are time, right? So you spend the day 1 on the 0, and then next day by steering you go by the even, then you go next, right? So 2 days, you spend 2 days. Okay. For this one, 6, right? You can check that. Okay, maybe let me just check it for you, right? So if 0, 0, 2, you spend this, you see day 0 go this. And the day one you still read this, right? And the day, so you can go to next, right? You go to 1, and you need to go to 0, go back to 0, 0. Because you go back to 0 is do the same thing, right? 0, 0. And then now you go to 1, you go to 2, right? Now go to 1 because you finally arrive here, and the second time you arrive here, this is even. Then you can go to the next, right? So total is I think it's 6. Okay. And you can check this. Okay, so this problem looks very difficult, very hard to see, but you can solve this into DP. Okay, so let me just tell you guys the answer. The answer is very simple. Once I write down the answer, then you guys will feel this problem is very stupid. Okay, so let's do this. Let's do this. So let me just define a T of I to be the first day, the time, I should say the time. The time for the first day you arrived at I. Okay. Okay, so boundary condition is trivial, right? T of 0 must be 0. Okay, so the thing is that how do we connect T of so suppose I already know T of 0, T of 1, T of 2 up to T of I. How can I solve I plus 1? Okay. So suppose this is the mathematical induction. Right? Suppose I know T0, T1, T2 up to T of I. How do I know Ti plus 1? Okay, so suppose this is I plus 1, and this is Ti plus 1. Right, so by the rules, if you want to go Ti minus 1, then you must start from Ti. Right? You must add I points and go this, right? So the idea is that right, you must start from this place and go here, right? So, but by definition, you must arrive this point twice because it's only even that you can go next, right? So that means this is the second time you arrive here, right? So what is the previous, right? The previous is R time, right? So you go to the T. Right, so let's just do it. Suppose, so now you know that you must visit I twice, right? So you start from 0 and then spend the T of I, right? Arrive here. So next that you will go to T next visit I, right? So next you spend one step, right? And then go to the next visit I. Okay, so you start from 0. Let me just write down. You start from 0 and then go to I, and then go to next visit I. Okay, so you spend T of I on this step, and then one step, right? By definition. And then what is the step that you can go back to I? Okay, easy. You can easily say that. Easily see that this is periodic, right? So you must the time you spend from next I to I must be t of I minus t of next of I. Next visit I. Okay, so let me just maybe this is not good. Let me just re-clear and redraw a picture. Okay, so let me just step one. Just go to 0 to I, right? So you spend, this is your cost, right? Your cost t of I by my definition. And the step one, let's say step 1, and you go to I to what? You go to I to next I. So let me just write t of ni. Right? So go to ni, right? So let's take one steps. And the step 3, that step 2 is how many steps you go to ni to t, right? So just n of I, this spend t of I minus ni. Now you arrive the i's position twice. So finally, you spend you go to I to I plus 1, which is t of I plus 1 equals to total step, right? So 2 of t of I plus 1 minus n of I plus 1, right? So it's just basically ti plus 1 equals to 2ti plus 2 minus ni. Recursion. Okay, that's it. Okay, so very simple. That you define n to be the length and the arrive time to be 0 times n. Okay, and then you would define mod. And for each 1 to n, you arrive time I is arrive I minus 1 times 2 minus next arrival time next with I minus 1 plus 2. And the modulo mode. Okay. And it's very elementary that your modulo mode is the same as modulo commute with the addition and the multiplication. Okay, so this is our recursion. Okay, so you see t of I plus 1 is 2ti plus 1 minus plus 2 minus n, I should say t of ni. Okay, right, so it's just this. Okay, so very simple problem. Once you know the recursion, this problem can be solved immediately. Okay, see you guys next videos.